Structure of the Earth. Detailed explanation. Overview. The Earth is made up of concentric layers, each with different composition, temperature, and physical properties. There are three main layers: crust, outermost; mantle, middle layer; core, innermost, divided into outer and inner core. Let's begin with the crust, the outermost skin of our planet, and the one we live on. Thickness. The continental crust is about 35 to 70 kilometers thick, while the oceanic crust is thinner, just 5 to 10 kilometers. Composition. Continental crust is made of granite, rich in silica and aluminum, also called sial. Oceanic crust is basaltic, made of silica and magnesium or sema. State and temperature. The crust is solid, but don't be fooled. Temperatures can still range from 200 degrees Celsius to 400 degrees Celsius below the surface. Interesting fact. Though it's the thinnest layer, the crust holds all life, oceans, continents, and every mountain and forest you've ever seen. It's the most familiar part of Earth, yet just the beginning of what lies beneath. Now we move deeper into the Earth, to the mantle, the middle and thickest layer of our planet. Depth and thickness. The mantle starts just below the crust and goes all the way down to 2,900 kilometers deep. That's a massive thickness of nearly 2,900 kilometers. Divisions. It's divided into two main parts. The upper mantle, which includes the asthenosphere, a soft, semi-molten layer, and the lower mantle, which is more rigid and dense. Composition. The mantle is made mostly of silicate rocks, rich in iron and magnesium. State and temperature. It's mostly solid, but behaves like plastic, meaning it can flow slowly over time. Temperatures here range from 500 degrees Celsius near the top to a blazing 4,000 degrees Celsius deep down. Interesting fact. The asthenosphere in the upper mantle is like a conveyor belt. It allows tectonic plates to float and slowly drift, causing earthquakes, volcanoes, and the movement of continents. Though we can't see it, the mantle's slow motion is shaping the very surface of our world. Let's journey even deeper, into the outer core, the only fully liquid layer inside the Earth. Depth and thickness. It begins at a depth of about 2,900 kilometers. And stretches down to 5,100 kilometers. That's a massive 2,200 kilometers thick. Composition and state. The outer core is made of liquid iron and nickel. Yes, metal in liquid form, swirling constantly under intense pressure and heat. Temperature. Temperatures here range from 4,000 degrees Celsius to nearly 6,000 degrees Celsius, almost as hot as the surface of the sun. Key function: Earth's magnetic field. And here's the most amazing part. This moving liquid metal creates electric currents, which power Earth's magnetic field. It's what protects us from harmful solar radiation, like an invisible force field. The outer core may be out of sight, but it plays a crucial role in protecting life on Earth. We've reached the very heart of our planet, the inner core, the deepest, hottest, and most extreme layer of Earth. Depth and size. It lies between 5,100 kilometers and 6,371 kilometers deep, right at the center of the Earth, with a solid thickness of about 1,200 kilometers. Composition. It's made up of solid iron and nickel. But here's the twist. Temperature and pressure. Even though temperatures soar up to a blazing 6,500 degrees Celsius, the pressure is so intense, millions of times higher than surface level, that it keeps the metal completely solid. State and significance. This superheated metal ball may be smaller than the Moon, but it plays a key role in stabilizing our planet's magnetic field, and even helping Earth maintain its shape. The inner core is Earth's indestructible engine, a solid sphere of metal, silently powering the planet from within. Let's quickly recap the four major layers of our Earth, from crust to core. 1. Crust. The crust is the thinnest layer, just 5 to 70 kilometers thick. Made of silicate rocks called shale and sima. It's solid and supports all life. Temperature: around 200 to 400 degrees Celsius. 2. Mantle. Next, the mantle, nearly 2,900 kilometers thick. Composed of silicates, magnesium, and iron. It's solid near the top, but semi-fluid deeper down. Temperature ranges from 500 to 4,000 degrees Celsius. 3. Outer core. Then comes the outer core, about 2,200 kilometers thick. It's made of liquid iron and nickel, and that motion generates Earth's magnetic field. Blazing temperatures from 4,000 to 6,000 degrees Celsius. 4. Inner core. And finally the inner core. A solid ball of iron and nickel, around 1,200 kilometers thick. Despite temperatures reaching nearly 6,500 degrees Celsius, enormous pressure keeps it solid. Each layer plays a vital role, from holding life, to moving continents, to generating the shield that protects our entire planet. Key terms. Lithosphere equals crust plus uppermost part of the upper mantle, rigid tectonic plates. Asthenosphere equals below lithosphere. Semi-molten allows plate movement. Sial equals silica plus aluminum, continental crust. Sima equals silica plus magnesium, oceanic crust. Layers of the atmosphere. Total layers. 5 main layers from bottom to top. Troposphere. Where life and weather exist. Height: 8 to 18 kilometers. Higher at equator, lower at poles. Features: closest to Earth's surface. All weather phenomena occur here. Clouds, rain, storms. Contains 75% of total air mass. Temperature: decreases with height. Special fact: airplanes fly at the upper boundary, tropopause. Stratosphere. Home of the ozone layer. Height: 18 kilometers to 50 kilometers. Features: contains the ozone layer, absorbs harmful UV rays. Very stable layer, no turbulence. Used for weather balloon and jet plane travel. Temperature: increases with height, due to ozone absorbing UV. Special fact: safer for high-altitude flights due to calm conditions. Mesosphere, meteor protection zone. Height: 50 kilometers to 85 kilometers. Features: meteors burn up in this layer due to friction. Very thin air. Hard to study directly. Temperature: decreases with height. Coldest layer, -90 degrees Celsius. Special fact: most poorly understood layer. 4. Thermosphere. Hot and electrified layer. Height: 85 kilometers to 600 km. Features: contains ionosphere, reflects radio waves. Auroras, northern/southern lights, occur here. Space stations and satellites orbit in lower thermosphere. Temperature: increases rapidly with height, 2,500 degrees C or more. Special fact: despite high temp would feel cold, low air density. 5. Exosphere, edge of the atmosphere. Height: 600 km to 10,000 kilometers. Merges into space. Features: extremely thin air. Atoms/molecules escape into space. Satellites orbit here. Temperature: varies. Difficult to measure accurately. Special fact: no definite boundary between exosphere and outer space. Key mnemonic, bottom to top. The silly monkey takes elevators. Equals troposphere, stratosphere, mesosphere, thermosphere, exosphere. Quick reference table. Layer height range temp change key feature. Troposphere 0 to 18 kilometers, decreases weather, breathable air. Stratosphere 18 to 50 kilometers, increases ozone layer, jet travel. Mesosphere 50 to 85 kilometers, decreases meteors burn. Thermosphere 85 to 600 kilometers, increases aurora ISS orbits. Exosphere 600 to 10,000 km plus varies fades into space, satellites.